Hey guys, good morning. Mr. Hall here. Today I want to get started with the 8th grade review. Your 8th grade teachers have chosen a few topics that we felt were most useful for you next year when you move on to Algebra 1. So in this first week we're going to spend some time working on solving equations, multi-step equations. So let's get to it. When solving equations, there is an order to the process of solving equations. I like to use as many mnemonic devices as I possibly can to help you to remember the order. So for my guys, we teach don't chase snakes carrying candy. Now that DCSCC represents something in the process of solving equations. The D stands for distributive. So anytime you see a distributive property, you're going to do that first. That first C stands for combining like terms, meaning all variables that are the same, all constants, they can all go together as long as they're on the same side of the equal sign. The S stands for write it in standard form, meaning get all the variables on one side. In this first lesson that I'm going to teach you, we are already going to have all the variables on one side. The next lesson that you see will require you to put all the variables all on one side. That first C that you see means move all the constants, which are all of the numbers that are not attached to variables. And then lastly, get rid of the coefficient. And the coefficient would be that number that's in front of the variable. Remember that when you're doing your standard form and your constants, when you're moving those back and forth from one side of the equal sign to the other side, you're using the additive inverse process, which just means if there's a positive, you're going to use a negative to get rid of it. A positive and a negative make nothing when we put them together. And then lastly, when you're getting rid of your coefficient, you're going to need to use the multiplicative inverse property in order to get rid of it. Okay, just a quick review of that process. So don't chase snakes carrying candy. Distribute, combine your like terms, get it into standard form, which means get all the variables on one side, move all your constants to the opposite side of your variables, and then lastly, get rid of your coefficient. Let's do a couple of examples together so that you can see what I'm talking about. All right, first of all, in example number 1 here, do we have any distributive? No, so we don't have to worry about that. First C, can we combine like terms? Well, yes, we can. Here's our equal sign. And on this side of the equal sign, we have a set of variables here, and we have the same set of variables here. Remember, the sign in front of the coefficient goes with it. So I'm just going to use circles here. This 2x doesn't have a sign, so we're going to assume that this 2x then is a positive 2x. So I'm going to go ahead and I'm going to circle this 2x, and I'm going to throw a positive sign out here for me just to remember that that thing's positive. This is another variable. It's the same variable, and I'm going to include that sign in front of it as well. Okay? I think that's it. Don't think there's any more sets of x's over here, so let's take these two now and put them together. So just using our integer rules, I got a positive 2 and a negative 5 that I'm putting together. If the signs are the same, we add the numbers, keep the sign. If the signs are different, we subtract the numbers, keep the sign of the bigger number. So we've got a positive and a negative. Signs are different, so we're going to subtract 5 minus 2. We get 3. 5 is bigger than 2, so we're going to keep the sign of 5. So we've got a negative 3x over here after we've combined those like terms. And this is the only constant on this side. So this guy's going to stand all by himself. He stays. And on the other side, there's nothing else over there except for the solution, so we're going to leave that guy. We've now combined our like terms. Now we need to get the S, we need to get it into standard form, meaning we need to get all the variables on one side. I think there's only one set of variables in the entire problem, so we don't need to do any more than we've already done. Now we move on to the next piece, which is the C, the first C, move the constant. The constant is the number on the same side with the variable that's not attached to the variable. So this is what we're solving for. We're solving for the x. This would be the coefficient. That's the last thing we're going to move. This is the constant. This is the number that's not attached to the variable. So now, as I shared with you at the beginning, To get rid of it, we're going to use our additive inverse. There is a positive 4, so we're going to do the inverse of that. We're going to subtract 4, and we're going to do that on both sides. Because we did that, our positive 4 and our negative 4, this guy makes nothing. So we know negative 3x plus nothing is equal to negative 3x. We call that the additive identity property. And then on the other side, we do what it says. Use our integer rules again. If the signs are the same, we add the numbers, keep the sign. So we're going to have a negative 12. Last step in the process, get rid of that coefficient. So the thing holding these two together, right now the negative 3 and the x are being held together using multiplication. We multiply when there's a coefficient in front of a variable. So I've got to do the inverse of that. To get rid of the coefficient here then, we're going to need to divide. The opposite of multiply would be divide. We'll use the fraction bar to show division. And I want to get rid of that 3 on both sides, but I also want to get rid of this negative. I don't want to keep that, so I want to get rid of that negative as well on both sides. So the negative 3 here and the negative 3 here, this guy gets rid of this guy, which leaves me just the x. And that's equal to 12 divided by 3. I'm not going to worry about the signs yet. So 12 divided by 3 is 4. And a negative divided by a negative. Now you're going to use your double trailer rules. A negative and a negative make a positive. So I'm going to leave my answer as a positive. So in example number 1, x is equal to 4. Let's go try another one. Add a few more details to it. So in example number 2, we got a lot more stuff. So go back through our process. If we use that process that I showed you earlier, is there any distributive? No, we don't have to worry about that. So move on to our first C. Can we combine like terms? Yes, on this side of the equal sign, there are multiple sets of m's, and there are also multiple constants here. So we can put all those together. So I'm going to use a circle for all of my m's. So I'm going to put a circle around this m. Remember, I'm going to include the sign that's in front of it. Put a circle around this m, and I'm going to put a circle around this m with the sign that it goes with. Okay? Now I've got positive 4, so I'm going to use a different shape. I'm going to use a square this time, and I'm going to put a square around the other constant here. So all the circles are going to go with all the circles. All the squares are going to go with all the squares. We're going to put those guys together. So let's do that. Let's combine our like terms. This 5 doesn't have anything in front of it, so we're going to make that guy positive. So a positive 5m, a negative 2m. Signs are different, so we're going to subtract those numbers. So 5 minus 2 is 3. Going to keep the sign of the bigger number, and 5 is bigger than 2. So we've got a positive 3, and we're going to put that together with a negative m. Now there's no coefficient here, so remember we always assume if we don't see one that that coefficient is 1. So a positive 5m, a negative 2m, and a negative 1m, put those all together, I think we get 2m's. And then in this guy here, we got a positive 4 and a positive 3. Let's combine those constants. A positive 4 and a positive 3, signs are the same, so we'll add our numbers, keep the sign. So that's a positive 7, and that's going to equal our negative 11 that we have on the other side. Okay? So the next step of that process is done. We've combined our like terms. Now we got to get it into standard form. We got to get all the variables on one side. So if we look at what we got, I think there's only one set of variables left. So we don't need to do any more with that. Our standard form is good. Now we got to get rid of the constants. So all the constants have to be on the opposite side of the variables. So here's the variables. We want this constant then to go on the other side. We're going to use our additive inverse, subtract 7 on both sides. If we subtract our 7 on this side, this all turns into nothing. And anything plus nothing is that same anything. That's our additive identity property. So 2m plus nothing is 2m. And that equals, over on the other side, use your integer rules. Signs are the same, so we'll add our numbers and keep that sign. Last step in the process, let's get rid of that coefficient. So to get rid of the coefficient, the 2 and the m are being held together using multiplication. So let's do the inverse of that. Let's divide on both sides. And we're trying to get rid of this 2. so we're going to divide by 2. Okay, so 2 divided by 2 is 1, and 1 times m is m. So we've just got m left equals 18 divided by 2 is 9. A negative and a positive make a negative. If the signs are the same when we're multiplying and dividing, if the signs are the same, that's good, that's going to make a positive. If the signs are different, that's bad, it's going to make a negative. That's 2 examples. Let's go to a third example. Okay, back to our process again. First, let's distribute if we can, or if we need to. In this case, we do need to distribute. There is a number out in front of the set of variables. So remember, when we distribute, we take the first number, or the number that's outside the parenthesis, and we multiply it by the first term, and we multiply it by the second term. Remember, the sign in front of the term travels with it. So I'm doing 4 times x. Well, I can't get a number for that, but I can do 4 times x, which is just coefficient in front of the variable. And now 4 times a negative 3. 4 times negative 3 is negative 12. Remember, this negative is going with that 3. And then equals our 8. Now, back to our process. Let's combine like terms. Well, in this case over here, we got one set of variables, but there's no other variables over here with it. We have one constant and no other constants with it. I think on this side we've done as good as we can, and of course this is our solution. There's only one term over here. We can't do any better than that. On to the next step then, get it in standard form. Get all your variables on one side. Well, there's only one set of variables in the entire problem, so they're already on one side, so we can move on to the next step. Get rid of your constant. So our constant, remember, is the number that's not attached to the variable. So this is not the constant. That's what we call the coefficient. This guy is our constant. So we're going to get rid of him. Remember, sign in front of him travels with him. So this is a negative 12. So to get rid of a negative 12, we'll use the additive inverse, and we'll do a positive 12. And we'll do that on both sides. A negative 12 and a positive 12, this all makes nothing. And 4x plus nothing is 4x. That's the additive identity property. And then on the other side, we simply do what it says. Don't make it harder than it is. 8 plus 12 makes 20. And the last step in the process, now let's get rid of that coefficient. Get rid of the number that's in front of the variable. So let's get rid of this 4. Multiply is holding these two together, so let's divide on both sides. Divide by the number that we want to get rid of. 4 divided by 4 is 1, and 1 times x makes x. That's our multiplicative inverse and our multiplicative identity properties. And then 20 divided by 4 is 5. That's our solution. Now, of course, if you wanted to check this, we can take this value that we believe is x, and we can substitute it. Put it back in the place here, solve it using your orders of operations, and you should get the same solution. Let's kind of put all that together then, guys. For example, in our final example, number 4. Let's do our whole process here. So first step, let's distribute if there is any. Okay? So here's my set of parentheses. We've got one term in front of it. This sign travels with this 5, so this is a positive 5. So let's distribute here. So this 2r, we're not going to do anything with that. He's not part of that process. Let's take this positive 5 and multiply. So we've got a positive 5 times r is positive 5r. And positive 5 times a positive 1 is a positive 5. Plus our 2, he's not in parentheses. We don't have to distribute with him. Equals our 28. Okay, so our distribution is done. We have simplified our expression. Now let's go combine like terms. On this side, I think we can combine. Let's go back to our circles. So we got a variable set here. We got another variable set here. Remember, sign in front of that goes with it. There's nothing in front of this one, so I'm going to put a positive. And then these guys are constants. They do not have variables attached to them, so I'm going to use a different symbol. So I'm going to use squares for these guys, and again, remember the sign in front of them travels with them. And then on the other side, we have our solution, and that's it. So let's now simplify those. So a positive 2 and a positive 5, that makes a positive 7. So we have 7 r's. And then we have a positive 5 and a positive 2 with our coefficients, or excuse me, our constants. So that's a positive 7. And on the other side, we keep our solution. Our solution is 28. Now we've combined our like terms. We now only have one set of variables and one constant. So the next step in the process, get it in standard form. Get all your variables on one side. So if I look at my problem, here's one set of variables, but there aren't anymore. So I already did that. We're good. Now I got to move my constant. So remember, constant is the number that's not attached to the variable. So this is not the constant. That's the coefficient. That's the constant. So we got to get rid of this. Remember, the sign in front of it travels with it. So this is a positive 7. So we're going to subtract 7. We're going to do that on both sides. We're using our additive inverse property. And 7r is left. This becomes nothing. 7r plus nothing is 7r. That's the additive identity property. And on the other side, we'll just do what it says. 28 minus 7 is 21. Now, last step in the process, let's get rid of that coefficient again. The coefficient is this guy here. Multiply is holding those two together. So we're going to do the inverse of that. The inverse of multiply is divide. We're going to divide by the number that we want to get rid of. So 7 divided by 7 makes 1, and 1 times r makes r. That's our multiplicative identity property, and 21 divided by 7 gives us our solution. So I think r is equal to 3. And again, we could take 3, plug it back in here. We could substitute, use your orders of operations, and go solve. And you have multiple r's here, so you'd have to put that same 3 in multiple places. I hope this was a good refresher for you. I hope you are all safe and healthy, and I hope this helps you to review solving equations. Have a great day, guys. Bye.